Hi, today we are going to study about the atmosphere which come under the flight mechanics subsection of the aerospace course for the GATE. So, atmosphere is the most important thing to consider, external factor to consider in aerospace engineering. Atmosphere determines how our aerospace vehicles, our aeronautical vehicles experience forces, moments, and the propulsion system, the control system works. So, at any point of time, aerospace vehicle would be interested in two parameters of the atmosphere, which are pressure and the temperature. The pressure and the temperature at any point, at any given point in the atmosphere, vary dynamically. Okay. These two parameters depend on many factors such as the location of the point, the time of the day, the season of the year, and solar sunspot activity. So to understand the atmosphere and its effects on the vehicle, we need to understand all these factors which are going to affect the pressure and the temperature in the atmosphere. Now, realistically, to consider all these factors together is very difficult. So, what we would be doing is we would be considering the properties of a standard atmosphere. Standard atmosphere is a hypothetical atmosphere whose properties are assumed to be constant. So when we know the location of the point on the earth, specifically the altitude of a point, then we can find out any of these properties, the pressure, the temperature, or the density. So before we study the standard atmosphere more clearly, we would understand some definitions which are very important to explain the standard atmosphere. So as I said, standard atmosphere can give us the pressure, temperature or density of any point if we know the altitude. The altitude is described as the point, as the distance from the surface of the earth. But technically there are different versions of the definition of altitude. So consider this as the earth and this point as the center of the earth. So for any given point, the distance from the center of the earth of that point is called the absolute altitude of that point. This circle roughly represents the sea level of the earth. So the other definition is analogous to that. So the distance of any point from the sea level at that location, the latitude and longitude, is called the geometric altitude of that point. Absolute altitude is used in absolute altitude is used in places where we are interested in the modeling of the aerospace vehicles. More specifically, space vehicles like satellites or interplanetary rockets. While geometric altitude is used where we are considering uh, small aeronautical vehicles traveling very closer to the Earth compared to satellites or interplanetary rockets. So both these altitude definitions are not used in the standard atmosphere, but a derived new definition for altitude is used in its place. We will try to study about it. So say HA is the absolute altitude and HG is the geometric altitude of any point. We would define a new altitude based on the property of pressure of the atmosphere. So hydrostatic pressure has this property where as the height increases, the pressure drops by an amount described by this equation. Here, rho is the density of the point, g is the acceleration due to gravity, and dh is the vertical distance traveled. In many cases, you can call this as the altitude of the point traveled. So this property is used to define the geopotential altitude. So as you know, the value of acceleration due to gravity depends on the distance from the center of the Earth. So g is a function of the absolute altitude of any point. So as pressure depends on variation of on the height, it also depends on the variation of the acceleration due to gravity. So to make it simpler, we would be defining a new kind of altitude such that it would relate to geometric altitude from this equation. So say HP is the geopotential altitude, then we define that minus G dHP is equal to G naught dHG, the geometric altitude. Here HP is the geopotential altitude, G is the local acceleration due to gravity, G naught is the acceleration due to gravity at sea level, and Hg is the geometric altitude. Like geometric altitude, geopotential altitude also starts from the sea level. So Hp at sea level is equal to 0. So when we integrate this equation, we get a simple relation between the absolute altitude, the geometric altitude, and the geopotential altitude. This equation can be stated as Hp, the geopotential altitude, is equal to Ha minus Hg upon Ha into Hg. So if you know the geometric altitude and the distance and the radius of Earth, to find out the absolute altitude of that point, you can find out the geopotential altitude. So all the references of pressure, temperature and density given in the standard atmosphere are related to the geopotential altitude of the point. So we'll stop here.